videos with you guys, I'm going over how you can actually solve the trig identity. Really ever used it. White. Um, so you can see this. So one of the problems, let's say we give you guys cosine of theta equals 1/3. And I want to figure out the other six trig functions for this. Now, one way you could do it is, like we've learned, right? Sine is uh, right? So cosine, this is simply thinking about a triangle, right? And here's our angle. Cosine is the adjacent over hypotenuse, right? So this is the adjacent over hypotenuse. So if we're looking at this angle, this will be adjacent, this is opposite, this is hypotenuse. And you could do your Pythagorean theorem, 1 squared plus x squared equals 3 squared is 9. 1 subtract 1, get x squared equals the square root of 8, which we know is the 4 and 2, so that's 2 square root of 2, because it breaks up into a 2 and a 2, right? Um, so this will be 2 square root of 2. So we could use that to find the rest of them, okay? So this will be 2 square root of 2 over 3. Now cosine tangent will be opposite over hypotenuse, so 2 opposite over adjacent, 2 over 1, which is that. Cosecant would be 3 over the square root, 2 square root of 2. And we would multiply this by the square root of 2 on top and bottom to reduce it. So 3 square root of 2 over 2 times 2, which is going to be 4. So 3 square root of 2 over 4. Secant would be this one flipped, that's 3. And then cotangent would be this one flipped, so 1 over 2 square root of 2. And again, we would multiply by the square root of 2 on top and bottom. This will be square root of 2 on top. 2 times 2 would be 4. So we would leave it like that. Okay. Now, there is another way we could do it. We could also use our identities that we just learned in class. to figure this out. So remember, one of our identities is sine squared of theta plus cosine squared of theta is equal to 1, right? And so what we could do is we could actually plug in what we know. And so this cosine is equal to 1 over 3, and we could square that plus x squared, right? We could let that be, or we could say sine squared. Let's leave it as sine squared. And we could solve for this. So this would be 1 over 3 squared. This would be 1 over 9 plus whatever this is. I'm going to let the x squared subtract 1 over 9. Now I think 1 minus 1 over 9 is the same as 9 over 9 minus 1 over 9. That'll be 8 over 9. So that's going to be equal to your x squared. And then we just need to square root this, square root that. And so think about the square root of 2 square root 2 over 3. And notice this is what is equal to your sine. That was and notice here we get the same thing. Okay. So just another way of solving this. And since this depends on which way you'd like to do it, is the way of solving. Something else. So one other thing that I did not cover on your minus sine of 30 degrees over cosine of 30 degrees. As long as these measures are the same, we can actually simplify this. I know that sine theta over cosine theta is equal to the tangent of theta. Okay, as long as these are the same, we can use this reciprocal identity or quotient. This one's the quotient identity, one of your identities. And so this is going to be the tangent of 30. And we know that the tangent of 30 degrees minus the tangent of 30 degrees is going to be 0. Okay, another way to use it. One more. Let's say we had tangent of 10 degrees, cotangent of 10 degrees. All right. Well, we know that we could think about it like this. Cotangent is 1 over tangent, right? So we could do this. And what happens to these? Those will cancel out, and so you're left with 1. So again, cotangent, remember, is equal to 1 over tangent. Okay. So it's important that you know all of these, okay? Because it helps you solve problems in a simpler way. All right, another thing we're going to talk about is complementary angles. We didn't really get to this either. We know that complementary angles at 90. Okay. And know is that cofunctions of complementary angles are equal. So I'll go into that in just a section. Okay. Cofunctions of complementary angles are equal. So what that means is that if you have sine of some angle measure, I'm going to let that theta, which be BFC, that's going to be equal to the cosine of A, okay? And the cosine of theta is equal to of theta, which B over A is equal to the cotangent of A. And cotangent of beta is equal to, and secant of beta is equal to C over A, which equals to cosecant. And the same thing as the cosecant of beta is equal to secant A, which is equal to C over B. All right, so from this, let's see what I've talked about. Okay. Sine is going to go with cosine. We're not talking about reciprocal. We're about the sine of 30 degrees. That's going to be equal to the cosine of 60 degrees, because again, we're looking at complementary angles. So you think about 90 degrees, the same as cotangent of 50 degrees. Uh, 90 degrees. So for example, I give you guys the problem tangent of 12 minus cotangent of 8 degrees. Well, the nice thing is, if you look at this, I can say, okay, well, this is the same thing as what is cotangent 90 minus 12, right? So it was 8, 10, 7. So cotangent of 78, these are the same measure. So if I did this one, what is that going to be equal? Cotangent of 78 minus cotangent of 78 is going to be equal to 0. Okay. We couldn't do anything with this originally because these are not the same measures, but I can make them the same measures by using the complementary angle theorem. Okay. So that's how we would actually use this in real time. Okay. Same thing, another one. What about this one? 1 plus tangent squared of 5 degrees minus cosecant squared of 85 degrees. All right, this is the same thing as, well, let's get them the same measures. So cotangent squared of 85 degrees minus cosecant squared of 85 degrees plus 1, right? Right, now they're the same measure. So now that I have these as the same measure, notice again, same 3 measure, I can see, okay, is there an identity that I could use that actually goes with that? And one of your past second theorem identities actually uses cotangent and cosecant. And if you identity is 1 plus the cotangent squared theta is equal to the cosecant squared theta. So can I turn that into this somehow? Well, look, if I do, if I move it over, right, or I move this one over, I'll subtract the 1 over here. And I'm going to move this over. So cotangent squared theta minus cosecant squared theta is equal to -1. So all of this is going to be -1. So you end up with 1 minus 1, which then gives you the 0. Okay, so just another way of solving the theorem. That's pretty much all of 7.2 that I covered. You guys should be able to solve some of these in the book, and let me know if you have any questions. Okay.